Jai Hind all. My name is Arun Kumar Maurya, Assistant Professor in the Department of Electrical and Electronics Engineering at AKGEC Ghaziabad. In the lecture series of Power System 1, the topic is mechanical design of transmission line. Actually, this topic is also important for the third year and final year for their placement drives. Such type of questions and the concepts asked in the interview questions and the uh, placement drive questions as well. So this topic is a hot topic for the electrical and electronics engineer and also used for the industrial point of view. So if we see the content, the first one is mechanical design of transmission line and what are the factors affecting to the sag for the overhead line and what are the formulas and the procedures to calculate the sag and what are the other factors to imposition of it and effect of wind and ice loading. We will see the what will be the effect of uh, atmospheric conditions such like that wind and ice loading and the other factors as well to see the impact on sag. So if we talk about the mechanical designing of the transmission line, so first we will see the what is sag. So sag is nothing but it is the difference in the level between the points of support and the lowest point on the conductor is known as the sag. It is the level between the points of supports and the lowest point on the conductor is known as a sag. We will see in a diagram. You may reference it. And if we talk about the span, which is the length, so it is the distance between two intermediate supports for a structure. Example, a beam of a bridge. Beam of a bridge is a generalized example which we have seen in the surrounding as well. If we see the diagram, so the level 1, this is level 1 and this is level 2. So the sag, this is the sag. Sag is the differentiate in the level between the points of supports. These are the supports and the lowest point on the conductor is known as sag. And span is the distance between the two intermittent support. That is, this is span. So this is the distance between the two intermittent supports. And the other things that is the surrounding clearance and the other all we will see in the next slides. So the point is that what are the factors affecting for the calculation procedure for a overhead transmission lines. So the first one is weight of the conductor. So this affects the sag directly. First one is heavier in the conductor, greater will be the sag. Heavier the conductor, the sag will be greater. So weight of the conductor is directly proportional to the increment of sag. In the location where ice forming takes place on the conductor, this will also cause increasing the sag. So if we see in a rainy season, some ice forming would have to be done on the conductors on the overhead lines in the hilly areas as well in the winters. So the sag will be high. So we can easily say that the ice imposition of the conductors affects to the greater the value of sag. So it affects directly. And other point is length of the span. What would be the effect of the distance between the two intermittent level and the supports? What will be the effect? So sag is directly proportional to the square of the span length. This is the very important and the crucial point for the third year and final year students related to the questions of power system transmission and the distribution. In the most of the interview questions asked in the manner, what will be the effect of such type of things on the calculation and the formulation of the same. So this is a very important point, I believe. We will see the calculation of sag, how to calculate and the formulate to the sag. So consider a point P on the conductor, taking the lowest point O as the origin. Let the coordinate of point P be X and Y. So in this C, we have seen this point P, and the point is O, which is the lowest point of the conductor, that is O, and let the coordinates of point P be X and Y. We easily say that in the horizon this is X and this is Y. If we see the point P, assuming that the curvature is so small that curve length is equal to its horizontal lines, so that we see the projection of is OP equal to X. The distance from the O and the P, which is that the horizontal line, this is X. Okay, the weight at Wx of conductor acting at a distance of X by 2. This is distance X, and the half of the distance is X by 2. This is the distance of X by 2 from O. The tension acting on the T is tension. The tension acting on the T, which is point at O. So the tension, this is T. So the we have seen the total distance is L. This is span and point O from. So the distance is L by 2. L by 2. And W is the weight of the per unit length of conductor, and T is acting at that tension, which is T from the point O. So we will see the different cases of calculating the sag. The first one is supporting at equal levels. We will calculate and formulate the sag which is at a support sets equal levels. So if we see, this is conductor, the support A, and this is support B, the point is O. So we will see these are the supports are the equal level. This distance and this distance is same. This is the meaning of support sets equal level. Basically, the support 1, support 2, level 1, level 2. Question may be asked in a interview in a other way, in saying that what is the formulation and the calculation procedure to see the sag at a same level from the clearance. So the clearance is the ground clearance. This is ground clearance. So the total length is L, and this distance is L by 2. Okay, and this is point 2, this is A. So the horizontal distance is X, and the midpoint is from the A, the distance is X by 2, and this is also X by 2. Tension is just acting T. So can we see that tension T by equal to W into X into X by 2, and so the y equal to W X square by 2T, and the maximum dip or a sag is replaced by the value of y at either of the supports level A and level B. So at support A, x equal to L by 2, we have seen in the diagram, and y equal to S. So sag S equal to W L by 2 square divided by 2T. So W L square by 8T. So sag S equal to W L square by 8T. So as represents sag, W is the weight of the conductor, L the span length between the two intermittent supports at the levels A and B, and T stands for the tension acting on the point O. So this is case 2, when we will see the calculation and the formulative procedures for a sag at a different level. In the previous case, we have seen the supports are at equal level. So the distance from B to O and the distance from A to O is same. So this is the same level of supports. So we have calculated the sag, and that is come out to be as equal to W L square by 8T. So in this second case, we will see the supports are at a different level. So this is the conductor, and the point A is it, and the point B is this. We will see this is level 1 and this is level 2, and the point is O. So what are the effect of sag while we see the supports at a different level? So L is the span length between the two supports A and B. So this is L. This is L, and H equal to the difference in level between the 2 points. So this point is B, and this is here. So this S1, sag S1, S2. So this is the H, basically difference in levels between the two supports. X1 distance of supports at a level that is A from A, and X2 the distance supports at a higher level, that is the point B. B is a higher point, and this is taken to be as from O, and T is the tension in the conductor. So the sag due to the S1 is W X1 square by 2T. So the sag S1 equal to W X1 square by 2T, and from the point B we will see the sag S2 is W X2 square by 2T. So and X1 plus X2 the length, and this is total span. So the H heights from level A and B. So the sag calculation from the point A and the B. So H2 minus H1 equal to W by 2T X2 square minus X1 square equal to W by 2T X2 plus X1 X2 minus X1. Basically, it is nothing like that. A square minus B square equal to A plus B, A minus B. So this is X2 and this is X1 square. So X2 plus X1 into X2 minus X1, H2 minus H1 equal to W L by 2T, and this is H2 minus X1 because X1 plus X2 equal to L, the total length. From here we will replace it, and H2 minus H1 equal to H, which we have seen here. This is H2 and this is S1. So the difference between it, this is H. So H2 minus S1 equal to H. So H equal to W L by 2T into X2 minus X1. So X2 minus X1 equal to 2TH and divided by WL. So solving expressions of 1 and second, we get X1 equal to L by 2 minus TH by WL, X2 equal to L by 2 plus TH by WL. Having found X1, X2 values of S1, S2 be easily calculated. So these are the important considerations to the calculation and the formulation of a sag at a different level. So in the other way, in the content, I have talked about the what will be the effect of wind and the ice loading. So if we see, the weight of a ice acts vertically downwards, that is in the same direction as the weight of the conductor. The weight of ice acts vertically downwards to the same direction as the weight of the conductor. The force due to the wind is assumed to act horizontally, that is at right angle to the projected surface of the conductor. Hence, the total force on the conductor is vector sum of horizontal and vertical forces as shown in the figure. So this is the conductor and this is ice coating. So this is the wind pressure. The force due to the wind is assumed to act horizontally, that is the right angle to the projected surface of the conductor. So this is the pressure of wind and acting horizontally, and this is the diameter and this is the T thickness. So the effect of wind and the ice loading is the weight of the conductor per unit length is WT equal to W plus W I square plus W wind and its root. So where W equal to weight of the conductor per unit length and WI weight of the per unit ice length and the suffix I, so it should be seen as the ice weight, and so equal to the density of ice in the volume of ice per unit length. So the density of ice into pi by 4 d plus 2t का whole square minus d square into 1, and density of ice into pi into t. T is the thickness, t plus t. So W the weight, wind force per unit length equal to wind pressure into t plus 2t into 1. So this is to be seen as A. This is due to for wind pressure, and this is for eye pressure, ice loading. This one, this is theta. So this is the vector effect of wind and ice loading. So the conductor sets itself in a plane at an angle to the vertical where tan theta. What is tan theta? we can see W divided by W plus W I. This is per, perpendicular to the base tan theta. So if we see there, this is a theta. So W which is here. The sag in the conductor is given by S equal to W T L square by 2T. So this is the important formula for S equal to WT. So thank you so much for seeing the concept of sag and what are the effects to imposition of wind and ice loading due to the sudden environmental condition to the conductor of a transmission line. Thank you.